It's the TED Radio Hour from NPR. I'm Guy Raz. So, as we start the new year, there's some good news and some bad news about the future of the planet. So first, let's do the bad news. We'll get to the good news in a minute, but let's just get the bad stuff out of the way. Because the last time this amount of carbon dioxide was in our atmosphere was probably back in the Pliocene epoch, millions of years ago, when giant creatures like mastodons still roamed the Earth, when there wasn't much of an ice sheet, and what we now think of as Florida and New Jersey were totally underwater. And today, well, we're on track to exceed those carbon dioxide levels by a lot. In fact, by an unprecedented amount.
And this is changing our climate enormously.
This is Tim Kruger. He studies climate change at the University of Oxford.
So we will see temperatures rise very rapidly, and that will cause massive changes in terms of agriculture, natural systems, biodiversity. But it's more than that. We will also see the oceans becoming increasingly acidified, so more CO2 will move from the atmosphere into the oceans, and the pH of the oceans will come down, and that will affect organisms at the base of the food chain in the ocean with very severe consequences.
What is the maximum temperature rise that scientists think humans can deal with?
So most of the world, unfortunately not the country where you're based, but most of the world is committed to the Paris Agreement. And what that says is that we will aim to stop the temperature rise between 1.5 and 2 degrees above pre-industrial levels. If it goes beyond that, you will see species going extinct, you will see coral reefs being irreparably damaged. Can we as humans survive as the temperature goes up on the planet? Yes, probably we can, but it will be an impoverished planet that we hand on to future generations. So I think that we have problems around food security, we have problems about global leadership, about economics and the inequality there, and migration. But climate change is something that is going to affect all of those and is going to be made considerably worse by its actions.
Today on the show, we're going to explore all of those problems: climate change, our political systems, whether we'll have enough food to feed everyone, refugees and migration, and the growing inequality between the richest people and the poorest. And we're calling these the Big Five, ideas about the 5 biggest issues that will affect all humans, and whether, with help from some radical solutions, we can stop them. And as we heard from Tim Kruger, climate change is the biggest one of all, and the one that's kind of hard for people to really feel and grasp.
It's like a tidal wave made of treacle. It's moving towards us incredibly slowly, and we need to make sure that we are aware of it. But it's very difficult to alert people to the danger as this danger comes closer and closer because it seems so slow.
But here's a little bit of good news. Finally, right? Now, we could potentially stop this. If the world could get its act together, we might eventually reverse the effects of climate change. But it's going to take a lot of dedication, a lot of ideas, a lot of money, and a lot of work. Because not only do we have to reduce CO2 from the atmosphere, we also need to remove it.
And what most people don't realize is that the climate models that are used to understand how we can avoid crossing the 2-degree threshold, they assume that we have technologies that can take carbon dioxide out of the atmosphere.
Oh, wow.
They assume it at a massive scale. They assume that we can remove between 600 and 800 billion tons of carbon dioxide out of the atmosphere in the decades ahead. And these models are ones that also assume heroically optimistic levels of mitigation. So in reality, we are going to need to remove trillions of tons of carbon dioxide from the atmosphere in the decades ahead.
So how? What do you I mean, it sounds like you're talking about something bigger than, World War II and the Marshall Plan and the Manhattan Project all combined, like the biggest thing humans have ever done.
I think that we are going to face a multi-generational challenge to restore the atmosphere.
And not only does Tim think about removing all that carbon dioxide from the atmosphere, he's actually trying to do it. Here's Tim Kruger on the TED stage.
I work assessing a whole range of these proposed techniques to see if they can work. We could use plants to take CO2 out and then store it in trees, in the soil, deep underground, or in the oceans. We could build large machines, so-called artificial trees, that will scrub CO2 from the air. For these ideas to be feasible, we need to understand whether they can be applied at a vast scale in a way that is safe, economic, and socially acceptable. All of these ideas come with trade-offs. None of them are perfect, but many have potential. It's unlikely that any one of them will solve it on its own. There is no silver bullet, but potentially together they may form the silver buckshot that we need to stop climate change in its tracks. I'm working independently on one particular idea which uses natural gas to generate electricity in a way that takes carbon dioxide out of the air. How does that work? So the origin power process feeds natural gas into a fuel cell. About half the chemical energy is converted into electricity, and the remainder into heat, which is used to break down limestone into lime and carbon dioxide. It's actually generating carbon dioxide. But the key point is all of the carbon dioxide generated, both from the fuel cell and from the lime kiln, is pure. And that's really important because it means you can either use that carbon dioxide or you can store it away deep underground at low cost. And then the lime that you produce can be used in industrial processes, and in being used, it scrubs CO2 out of the air. Overall, the process is carbon negative. It removes carbon dioxide from the air. If you normally generate electricity from natural gas, you emit about 400 grams of CO2 into the air for every kilowatt hour. With this process, that figure is minus 600. At the moment, power generation is responsible for about a quarter of all carbon dioxide emissions. Hypothetically, if you replaced all power generation with this process, then you would not only eliminate all of the emissions from power generation, but you would start removing emissions from other sectors as well, potentially cutting 60% of overall carbon emissions.
So, okay, just so I understand this. Once this process is done, once you've removed the carbon dioxide from the air, the byproduct is limestone?
Yeah, that's right. So the whole process is kind of using the limestone as a kind of intermediate product. So you start off with limestone, you end up with limestone, but the net result of the process is that you have taken dilute carbon dioxide out of the air and generated pure carbon dioxide. And that's important because once you have pure carbon dioxide, you can bury that deep underground. If you've just got dilute carbon dioxide, you can't bury it underground as it is.
So when you say you can store away that carbon dioxide underground, what does that look like? Is it like a liquid? Is it a gas? Describe what it means to store it underground.
So what you do is you compress the CO2 into a state called a supercritical fluid, and that is something which is kind of partway between a gas and a liquid. It's got characteristics of both, and you inject it deep underground, and there it will react with the rocks and remain stored deep underground. So part of the storage is what's known as physical. It gets trapped in gaps underground, and part of it is chemical. It will react with the rocks underground. But basically, once you inject it, it stays there. It's down there for good.
So, as promising as this technology sounds, because it sounds incredible that we could actually start to, clean up the mess that we've created over the past 250, 300 years. It sounds a little bit like, a mission to Mars. Like humans know that we can get something to Mars. We've done it before. So we should be able to get humans to Mars. But there are some challenges, like how do you bring up enough water for a 6-month journey in a spacecraft, right? So, that'll be resolved at some point, but we can't do it right now. It sounds like it's similar to that this is not something we can implement today.
No, and it isn't something we can implement today. So we should not in any way cut back on any of our efforts to reduce emissions. So that's got to be the top priority. But even if we reduce emissions incredibly rapidly, it's not enough on its own. We need these technologies to take CO2 out of the atmosphere. It's not available today. It won't be available for many years to come. But we need to try. There's a story about a man who fell on hard times and he prayed and he said, please God, let me win the lottery, let me win the lottery. And he didn't win the lottery. And the next week he said, I'm in a real bind. I really need to get some money, let me win the lottery. And still he didn't win it. And the third time he climbed up to the top of a mountain and he said, I'm going to throw myself off. I'm going to kill myself. God, you've got to help me on this. And just as he was about to throw himself off, there was a roll of thunder and a booming voice rang out. He said, for goodness sake, man, meet me halfway. Buy a ticket. And that's what we need to do. We actually need to try. It's no good saying, well, we need to do this, and we actually need to put the resources behind it. The question comes, who would do this? And at the moment, really, no one. So we could have the ideas, but without there being some sort of motivation, some sort of incentive to do so, it's just not going to happen. We need to raise our game significantly if we are going to be able to address this problem.
Tim Kruger, he researches geoengineering at the University of Oxford. He's currently working on a smaller prototype of the technology he described on the TED stage. You can see his full talk at TED.com. On the show today, the 5 biggest problems that face the world and what we might do to stop them. I'm Guy Raz, and you're listening to the TED Radio Hour from NPR.